Good day. So today we're going to be looking at further differentiation questions. So there are a few prerequisites that you must master. I think you know how to do basic differentiation. For example, if I give you a function like y equals 3x cubed, you must be able to differentiate that. Or find the derivative of that function. So in this case, if you differentiate y is equal to 3x cubed, you're going to get dy dx as your derivative, and the answer will be 9x squared. So this is one of the basic things you need to know before you jump into further differentiation. And then the next thing that you must know is how to use the chain rule. Again, the chain rule is used to differentiate complex elements, complex stuff. You use the chain rule when you have composite functions, like a function inside another function. So I'm going to demonstrate the chain rule briefly. So if you have a function like y equals 3x cubed plus 4x, and everything is raised to the power of 10, you may want to implement the chain rule, because you can't do the expansion, you can't write down all the 10 brackets and expand them. It will take a long time. So you need to know how to use the chain rule. You can watch out my other video and then get more on this. I'm going to be using the shortcut method here to differentiate this using the chain rule. So in this case, our dy dx will be, the first thing that you need to do is to differentiate the outer function. So our outer function is made up of this 10. This is the only part that is outside the bracket. So we're going to differentiate the red part, that 10 and the brackets. So if we do that, we're simply going to get 10, open bracket, we keep our inner function intact. So that's 3x cubed plus 4x. And then for our outer function, we decrease the power. We're going to get 9. All right. But the story doesn't end there. You still need to differentiate the inner function. So I'm differentiating the inner function in blue. So if we differentiate 3x cubed plus 4x, we're going to get 9x squared plus 4. So the blue part is when we were dealing with the inner function. The red part is when we were differentiating the outer function. So all you need to do is just to combine everything, combine all your answers. So these guys are multiplying each other, and the final answer will be 10. Write the smaller bracket first, 9x squared plus 4, and then that other big bracket with a power, 3x cubed plus 4x. So again, if you're confused, make sure you watch the other videos and before proceeding on. Okay, so let me quickly erase this and we'll focus on the core concept for today. Okay. All right, that's more about it. So, as you might have known from the other video tutorials I made, differentiation is used to find the gradient function. So if you have a curve like this, you can use differentiation to find gradient. Suppose at this point, you can use differentiation to find the gradient at that point. And normally, before you knew about differentiation, I'm sure you knew that for you to find the gradient of a curve, you need to draw a tangent. So differentiation will give you this gradient. So what we need to focus on today is to find the equation of the tangent. That's the first step. You need to know how to find the equation of the tangent. And later on, you also need to know how to find the equation of the normal. So these are the general steps that you need to watch out for. So the first step is to differentiate. Differentiate. And then the second step is to find the gradient. Find the gradient. For you to find the gradient, you do substitution. You will be given a point, so you just substitute the given x value into that function and you get the gradient. So I just write use substitution. Substitution of x only, not y. If you're given a complete set pair of coordinates x and y, you just use x. And then for you to find the equation of the tangent, and that's the last step. All you need to do is to use your gradient and the given point. Use the formula. Y minus y1 equals m x minus xy, where x1, y1 is your given point, and m is your gradient from step 2. All right, we won't waste much time. We want to apply these 3 simple rules to this question we have here. Okay, so let's see if we can scroll down a little bit. Okay, that's perfect. Let's use, I don't know what your favorite color is. Just gonna go with blue, make it thicker a little bit. So here we're given a function, and they want us to find the gradient of the tangent. So step 1, we have y equals 2x cubed minus 3x squared minus 1. So for step 1, we're going to be doing differentiation. So it doesn't matter the kind of function you're given. We assume that you know how to do the basic differentiation of various functions, so just differentiate it. So in our case, our dy dx will be 6x squared minus this 2 times the minus 3, that's minus 6. We decrease that power, minus 6x. And then if we differentiate minus 1, we get nothing, isn't it? We get 0. So that's fine. So we have done our step 1. Now we want to move on to step 2. Let me find another color here. Magenta, okay. So for step 2 now, we're supposed to find the gradient using the substitution. So here we're given the point. I'm just going to write the point. The point is 2, 3, which means that this guy is our x and this guy is our y. We're going to substitute the point x in our dy dx function. So I'll write dy dx again. Dy dx is 6x squared minus 6x. Now, to find the actual gradient, I'm going to substitute only the x value into our function, just this x value. So we're going to get 6. Our x is 2 squared minus 6. This is 2 again. And then this will give us what? This is going to give us 6 times 4, that's 24, minus 12, and the answer is just 12. So our answer for step 2 is 12. That's our gradient. Now we'll move on to step 3. We want the gradient, we want to find the equation of tangent. So for us to find the equation of tangent, we need to use what I said in the notes. Just use this equation, your gradient, and your point. So we're going to say y minus the given point xy will give us x1 and y1. So y minus, let me write the formula, y1 equals m x minus x1. So all you need to do is to plug in the values. So you're going to get y minus, our y1 is this 3. This is y1. So y minus 3 equals m, the gradient we just found, m is 12. X minus our x1 is the x from the given point. So our x is 2. And then this is how you find the equation of your tangent. So all you need to do now is to make it a little bit nice. So I don't have space here. I'm gonna write y equals 12 times x, that's 12x. 12 times minus 2, that's minus 24. Then we transpose that minus 3. It will become a plus 3 on the other side. And the final answer will be 12x minus 21. So this will be the final answer. And it doesn't matter how complex a problem you've been given. As long as you follow the 3 steps, you will definitely get the equation of the tangent. So make sure you join me in another video again, where I'll be showing you how to find the equation of the normal. But the basic process is this. You first need to find the equation of the tangent, and then you need to know how to find the equation of the normal. All right, see you next time.